hints for the quizzes and stuff, because this book
Hmm.
isn't easy to read. You know, math is another language that I'm not a I don't have strong aptitude with,
Hmm.
and it's even harder in a way when they put math into prose. So reading this textbook is, yeah, it's been tough.
I understand. Yeah.
Yeah.
So that's why I'm saying the math part. Uh, I try to just get rid of those. You know, the just calculation and then complicated formula inside. Yeah. Don't. I I hope you not fall into those details of it. I know it's a little bit challenging to just take the only just concept and understanding part, but uh, I'm not trying to make you just calculate those statistic value or formula understanding of a formula. That's okay. Eventually, a computer will do it for you. But for the emphasis part and through this office hour, and also for the quiz, the problems also, it's not about calculating any statistic or complicated calculation. So focus on concepts and understanding. Even though the question textbook itself is showing everything, I can tell every statistical textbook has a very messy the mathematics and the formulas inside. But the thing I choose this textbook is because this one literally relatively it's more onto a healthcare research and the tie with the a journal articles. That's the good thing about this textbook. And also it's a little bit less mathematics part than the other textbook. So that's why I choose this one. Yeah, you will see that a lot of a messy math part on other textbook. That's yeah, you're gonna vomit when you say when you check the text. What are the, when I checked that when I was a first graduate student, it was so difficult to follow up. You know, that's the all a derivation of the whole the mathematics and the deriving the whole things. I don't even know how the data is coming to and how the data is analyzing. It's all about mathematics as a calculating. But eventually I see that, but I'm not saying we have to ignore the whole mathematics, the formula part. But I just really want to empathize for this course is to just for you to understand about the concept first, right? Because I don't think you guys will be into this area to run the data and just do a lot of analysis by yourself, you know. But at least you're gonna understand. Oh, for this calculation, maybe I can work with that's the biostatistician or statistician. But when they give you, when they deliver the result to you, then you may understand. Oh, you will see that result. Oh, yeah, the p-value is less than 0.5. Oh, that's a significant result, right? Rather than
Yes.
asking, the statistician, oh, what this means, what's the result, or what's the conclusion of this one? No, but through the whole collaboration, then you will see that how the this concept, understanding concept, will be important for your research. Yeah. So even though you guys are into a CSD, the program, uh, you're gonna meet a lot of articles and papers, right? So about the patient research or all other a treatment research or other a different like the clinical the part. Those things you have to read clearly, and the statistics is essential to understand about those articles, right? So that's why I just added, attached the journal article so related to each module. So I hope you to check those things as well. Right.
Thank you very much.
Okay. Can I move on?
Mm-hmm.
All right. So those are about the let me see. Yeah. So those things about like also yeah. So far, we're gonna talk about like we talked about like a hypothesis testing and the steps of processing and the type 1 error, type 2 error, and the p-value. Those things. It's but at the level of the concept, just make sure. I'm not asking you about the calculating those, right? And these things are also behind this the textbook is all talk about different thing, but yeah, it's okay, not clearly about catch the every details of this one, but understand, try to understand, and if you have any question, then please let me know. Okay, just you can email me to just ask your the questions over there. So this one is like how we make a testing and how we calculate the test, the statistic, and how the p-value will be calculated, but you don't have to worry about this. But just conceptually, we did these 6 steps. 6 steps must be the necessary, but just as a conceptual part, it will be okay enough, right? So, so this is it for chapter 4. And if you have a chance, just please just go over the chapter review and multiple choice concept review. These questions might be quite similar to, I mean, I mean the format of the quiz maybe similar, and also maybe you could get the similar the question as well. Okay. All right.
Dr. Ohm,
Yep.
speaking of the chapter review, is it okay if we talk about question number 7?
Number 7 over here. Oh, okay.
I just was curious when we talk about that relationship between the alpha levels and the higher powers, and trying to answer the question that power can be increased by doing which of the following. When it says increasing the A level, I don't know, like it's not quite obvious in my, or maybe it is obvious. Increasing the alpha level would create that higher percentage of likelihood that
error rate.
There's error, making it less stringent, and therefore that's part of creating higher power?
No, actually, what we have is, since we allow this increasing alpha level means we get a higher value of error rate, right?
Okay.
So the things that we just have those error rate, it will be higher and higher. So eventually, when we have, this is about like a power calculation, but when we have like a higher error rate, that means that it's more difficult to just detect. No, it's the other way. It will be more require more higher power to detect those the truths, because there are a lot of errors out there, right? So that means it will be the power will be more required to be higher. And I think that's the thing we want to tell.
Professor, in this case, then the answer would have to be B, right? You'd have to increase the sample size, given these choices, right? Increasing the alpha level wouldn't increase the power, but increasing the sample size would, wouldn't it?
No. Increasing not only just increasing sample size, it also when we have like so for example, like the C increasing effect size, that means effect size is to be that's the difference to be detected. When we have like that difference is getting larger and larger, then it's more easily to be detected, right? So that's why the power will be increased. You see what I mean? As sample size increasing, definitely will have more power because we have more sample and the more accurate the like information from there. But when we have like an effect size getting also increased, that means we have more rooms to detect that difference. So for example, when the effect size is very tiny, that will require like a lot of sample that will be very difficult to detect, right? Then it will be not enough the power to detect those values. But when we have like those big the differences, then then calculation of power itself, oh, it's very easy to detect that those are the difference. Then the power automatically power should be the higher, because the power is the power ability to detect the truth, the true significant difference. So I think in that sense that the answer must be all of those.
I think,
Yeah.
Andrew, you and I have confusion because based on, if we go back to page 82, there's a paragraph, the last paragraph on that page talks about a number of strategies are available to increase the power of studies. And then it goes through 3 strategies. But the second one specifically says the second strategy is to use smaller effect sizes. So
yeah, you know, I think I saw it the same way. And then I went back, and alpha level is simply the statistical significance.
Right.
So increasing the significance is the way we should be reading that, and not changing it from 0.05 to 0.01, like you were showing the example, right? I think that's where my confusion was coming from.
I see. So increasing, yeah. Go ahead.
Oh, I think Drew and I have the same confusion, like what does it mean to increase alpha level? And you're saying it's significance?
Right, because alpha level is defined as the statistical significance, correct?
Yeah. So alpha level is just set up like to make when we set like allowing the error rate to be significant. So for example, when we set up like a point of 5, that means we allow like a 5% of like error rate, right? Then compared to like a 10% of error rate, so that means we allowing more loosely, but that makes we have like a much more power to just detect those the differences, because those are error rate we already accepted those apart. But if we have like a very strict the error rate should be just less than 0.01 or just a very tiny error rate, that means it's very difficult to approach to the level of like those alpha. So using your sample, it might be more difficult to detect the difference based on the significant alpha level. So that means when we say like, when we calculate your p-value, right? So compared to 0.05 and 0.01, then on the level like a 0.05, you can tell, oh, I see that's a significant difference between two groups because my p-value shows at 0.04, right? But under the 0.01 level, oh, it's not significant anymore. So that's related to the power issue. So 0.04 still shows that significant difference. That's showing that, oh, enough power to detect the significant difference because p-value indicate that. But under the 0.01 level, but that doesn't mean that increasing alpha is going down to 0.01. Increasing alpha level is going up, like a 0.1 and the 0.2, you know, then the significant p-value level is would be more easier to detect the differences. I don't know whether you guys understand what I'm saying. You guys get it?
Yeah, I think so.
Yeah. So power, I think is an example of like a p-value. You know, that'll be more easier to understand. So usually we calculate p-value, okay, for the testing. But the nominal, in general way, we set the alpha level as a 0.05, okay? Then our p-value shows that less than 0.05, then we tell the significant, statistical significant. But if we have a new alpha level, which is a very lower than the 0.05, which I'm saying just 0.01, then it's very hard to say the p-value. P-value should be less than 0.01 to say the significant. So that it will decrease the power. It's very not likely to detect those difference. But if you loosen the error rate, like a 0.1, a 0.2, high and high, then if the p-value is a little lower than that, still you can say, oh, that's a significant, right? So the significance is always related to the power. All right, that's it. That's okay.
Good for me.
I know it's very hard. This is a very tricky and the confusing part. Yeah, that's the starting of a question. So you could ask me a question individually if you're not catch about this concept. Okay. So this is about like a testing the power on those issues, and don't worry about this technical part. But we get into more details about it now. It's more on the specific testing. Okay. So we're going to talk about independent t-test and manuated u-test. Right? So you have to understand when do we use these two tests and to distinguish what's the difference between these two testings. So here at the title, yeah, check the title, measuring differences between the means of two unrelated. This title itself contains a lot of information. We want to compare the means or averages, right, of two groups. And those two groups are unrelated. Wow. So that means these two groups, it should be mutually exclusive. It cannot be overlapped. And unrelated, there should be two groups are independent, okay? And what we want to do is we want to compare the average of those each group. So for example, like a blood pressure level. Average of a SBP for one group and the average of a SBP for another group. I want to compare, right? Then we're gonna use an independent t-test and a manuated u-test. It sounds clear, right? But the thing is, let me go back. Right. So research question is all about like comparing the average between two groups. So over here, independent sample t-test. Independent sample t-test is assumptions will be met, should be met before you make this go into the real testing. So grouping variable. Grouping variable is what? You want to make make two groups. So you need a variable to distinguish those two groups. So for example, like a gender, female versus male, or just group 1 and group 2, or just a treatment or control group, then you may need that variable, right? So grouping variable, that's independent variable, must be dichotomous because we only need a two group, right? We can't do just 3 or more groups based on t-test. So what we need is only two groups. So that should be dichotomous, only two categories. And those two categories must be mutually exclusive. So it's not just mutually dependent, mutually distributed, mutually exclusive. It should be mutually exclusive. Okay, I clearly said that. Mutually exclusive. And the two categories must be independent of each other, do not influence of the values of another group or the other group, right? And the variable measuring the cluster of interest must be, this must be the outcome measure, normally distributed and continuous. This is very, very important the assumption as well. All right, so grouping variable and the categories independent and the outcome measure must be normally distributed and continuous. Then we could use a t-test, right? I'll tell you just one, yeah, just a lot of mistakes from like a researcher. They just ignore these assumptions. Computer is not that smart to check the all assumptions. The computer, it just will follow your order. So if you say, oh, just run the two sample t-test and then computer will do it. No matter what the data it has, usually computer will do it, right? So then if your outcome variable just not having just continuous measure and even for like not following the normal distribution, very skewed, then still it will show you the testing result based on the what you instruct to the computer, right? Then what will happen? It could mislead the result into wrong direction. So that's why it will be very, very careful to check all the assumptions before running any statistical testing. There are a lot of mistakes out there. They just run it and then just report it. But the testing result is totally misleading and biased. It happens a lot. Yeah. So that's about the t-test and the details how we calculate the compute like those statistic measure. Don't worry about that. Don't worry about that. But just check. Like I told you, we're gonna follow the 6 steps. So 6 step. Then the check the how they set up the state, the hypothesis, and then define the significant level is the same way as we set the alpha is a 0.05. Yeah, that's it. But for computing we have to check what the data met all the necessary assumptions. I told you about the assumption for t-test, but don't worry about this calculation. This calculation is just, you don't need to worry about this. Okay, what you need to care is to check step 1, step 2, step 3, how they just check them. And they will, anyhow, we're going to compute these necessary measures using the formulas. And step 5 also, and we're going to calculate this t statistic measure and compare that measure with this critical value, and calculate like a 95 confidence interval or just p-value, then draw the conclusion. So if I give you some questions about like these things, I will give you the already calculated like a statistic value or this everything there, for you not to calculate anything over there. Okay, so don't worry about the calculations. I'll just just skip that part. So based on the tested based on all the previous step result, then you can draw the conclusion and determine about statistical significance. So over here, you have to conclude that all null hypothesis can be rejected based on certain region you have. Here is just comparing the your t statistic value with the critical value. Then that could be the region also, and you can conclude that this one will be on the paper or article when you write up like any research paper. So in the sample, you have to mention that it's based on your sample. It's not just generalization. Your male dieter have the statistically significant greater diet weight loss than the female dieter over a 3 months period based on your sample. Okay, you can conclude that, and also if you mention p-value over here, there'll be more perceivable. Okay, so this is a steps for like a running SPSS, and which means the computer the statistical software. You don't have to worry about this. Skip that, and then skip this part as well. This is you can skip that. So the thing is the compare, here this one also talk about a lot of different ways of like testing for details. Yeah, don't you don't need to worry too much about those as well. Such concept, why we need a 2 sample t-test. What's the case for 2 sample t-test is needed, right? There'll be enough. Right. Understanding about conceptual understanding about independent sample t-test. These things is you may need to check closely. Okay, I just focus on the concept part, and you don't have to worry about this the details about distribution, about the test statistic measure. Oh, yeah, you skip this part. Sample size, consideration, power. Yeah, you don't have to worry about this one. This is beyond the level of our course. Yeah. So I want to talk about like a man-Whitney U-test. So far, we talk about the t-test, two-group comparison, mean comparison, and the outcome measure should be normally distributed and continuous. Then you may need to catch why we need a man-Whitney U-test instead of a two-sample t-test. Okay, so again, man-Whitney U-test is a non-parametric. Oh, then the two-sample t-test must be parametric, right? So this is more like a mathematical terms. Parametric is simply to say a parametric test is coming from the normal distribution. So I already just introduced about normal distribution. Normal distribution is a bell-shaped curve, and the mean, median, mode are all same. That's the standardized, most commonly used the distribution in the world. So normal distribution is the one as like a rule of thumb, as like a standard. But if our data outcome is not following the normal, then we cannot utilize a two-sample t-test. We may need to do another way. So man-Whitney U-test might be alternative way of testing. So non-parametric, and but the other thing is the same. Whether the relationship exists between two groups. So yeah, it still needs a two groups. But when one variable dichotomous, yeah, still is the same. And other variables at least ordinal, right? Since ordinal measure is not likely to follow the normal distribution. I know if you set like a ordinal, the ranges are pretty much wide, then possibly it could follow the normal. But for example, like a Likert scale, 1, 2, 3, 4, 5, and what if those distribution is very skewed to the right tail or left tail? It's not following the normal, right? Then we have to think about the other way about running the testing, which is that the alternatives is a man-Whitney U-test. Right. It could be used the situation which assumptions for independent t-tests are not met. So any of our assumptions is not met, then we may want to use a man-Whitney U-test. Okay. So man-Whitney U-test, yeah, it's a non-parametric test, and those things. But the details. But I want you to check this one. Step 1, how they set up on the hypothesis and define the alpha level. But instead of a t statistic, it's two-sample t-test is using the t statistic. T statistic is a complicated other distribution, but instead of t, what we're going to use is a u, right? So here is a man-Whitney U-test. We're going to focus on the U statistic, but you don't have to worry about how you calculate the U statistic itself. But
Professor, before you move on, can you just quickly, hopefully it can be quickly done. Can you just tell me what does a dichotomous variable? What is that referring to?
It's about like only making the two groups for like a gender. You have like a female, male, right?
Okay, thank you. So it's just very clear cut then.
Yeah, just two groups, only for allowing for two groups. And for example, like a yes or no, there should be only two groups, right? And the control versus intervention, there should be also two groups. That's the dichotomous.
Thanks. That makes a lot more sense.
Right. And assumptions, you may want to check, but assumption is here is a more loosened than the two-sample t-test. But the key, one of the interesting things over here is it's not compute average or mean. It's compute median and the interquartile range for each group. Two-sample t-test, what we calculated the average and the standard deviation to show it. But for this type of data, not met the two sample t-test assumption, then we may need to show medians and interquartile range. This is the differences. Okay, so we want to compute the median interquartile range for each group. This is a distinctive part, different part than the two sample t-test. And the using test statistic, eventually we're gonna show that like a p-value over here, running the whole the computing, the procedure, then make a draw conclusion. It's like determining the statistical significance and make a final conclusion based on the result. So don't fall into the details of how they calculate or how they measure those each statistic. Maybe if you really want to understand this formula and these calculations, please let me know. Okay, I'll introduce the other deeper like a level of course provided our graduate program that should be the more fit to that course, those like a calculation and mathematical theory. I'm saying this course is not about like calculating, deriving those formula. It just catch the only the concept part on the on also the understanding of the final result. That should be it. Okay. So yeah, two sample t-test also manual u-test and the two sample t-test we're gonna learn for this module, and to check the module, right? And to check the module with the voice recordings, then you can see that. Right. The textbooks are very thick, but I just summarize it very quick. I know it might be challenging, but just focus on what I describe on this office hour, and there will be no problem with the quiz questions. Anything else I just missed, or if you have anything, any question or any problem of just taking this course, or any comment will be fine.
So the participation grade is just kind of a given as long as you're assumed to do the reading and watch these videos and stuff, right?
Participation, yes. But it's very hard to judge it. Previously I tried to check the attendance and how you guys check that, but eventually you guys will be get there, and some of the students, you guys are participating well, but there is some of the students and not involving at all, like just taking the quiz is then not even check the any other material, and then I see that almost before the final, check the grade over there, and then they fall behind everyone. Then I try to just contact those the student to make up. Then eventually everyone will participate. Yeah. So individually, I'll check if anyone is not involving much. Yeah, I'll check. But
well, I can just say I do appreciate you trying to distill down some of this information.
Yeah.
The first couple of chapters I got pretty bogged down in some of these formulas. Thank you.
I understand. All right, just hang on, and you may feel that, oh, is it okay to skip this part this much? Yeah, that's fine. Yeah, I can tell that's fine for now, and you will see that from chapter 4 to like a chapter 8 or 10, the format of the whole the topics and the course format will be quite similar, you know. So it'll be very if we fall into the details about the mathematics, then it will take forever, really forever. So it wouldn't be enough to show the everything over here. But when I got the like a request from the department chair of CSD, he asked me to, you know, get rid of all the math and the complicated part, and then check the like a concept, and at least for you guys to read the articles and the papers without any big, you know, statistical problems. That's the main goal of this course. Okay, so I hope you to understand. And but if you want to know behind this course level, yeah, let me know. All right. Okay, and hope I'll post the quiz 2 information probably tomorrow, and also I'll upload the quiz 1 feedback when the quiz 1 is done. Okay. All right. Bye guys, and see you next week. Bye
Thank you.
bye.
Thank